In this question, we are looking at the sequence 6n squared over n squared plus 1, and we'll ask whether it's monotonic, bounded, and does it have a limit. So monotonic. Monotonic means that the terms are either always increasing or always decreasing. Always moving the same direction. So let's look at that. What does that mean? That would mean that if I had a function, that its slope would always be positive or its slope would always be negative. So the way that we're going to do that is turn this into a function. 6x squared over x squared plus 1, and then ask about its slope. The slope is the derivative, f prime at x, which by the quotient rule will be the bottom times the derivative of the top, plus the top times the derivative of the bottom, all over the bottom squared. And all I care about is whether this is always positive or always negative. Because if it's always positive, then this is always increasing. If it's always negative, then it's always decreasing. I don't care about the numbers, I don't care about the values. I only care about whether it's always positive or always negative. Which means that the denominator is going to play no role, because the denominator is always positive. So this is always positive. So I don't care about it. It's not going to affect whether or not we have something that's positive or negative, because it's always positive. So I really only care about this stuff. So that's x squared plus 1 times 12x plus 6x squared, well, plus 6x, let's make that 12x cubed. So this makes 12x cubed plus 12x plus 12x cubed. So that's 24x cubed plus 12x. Which is, I can factor out a 12x, and I get 2x squared plus 1. Now, remember that x is n, right? X is n. So what does that mean? If n, that means that since we only have positive values of n, this is always going to be positive just because it's a square. And this will also always be positive because for us, we're only looking at positive values of n. So since n is bigger than or equal to 0, this means this is positive. So that tells me that the entire thing is always bigger than 0 for positive n, or for x bigger than or equal to 0. Since the derivative is always positive, then it's always increasing. So yes, it is monotonic, always increasing. Is it bounded? Bounded means, are there numbers which are bigger than everything that we get when we plug in any value of n, and smaller than anything that we would get? In other words, if I were to draw this, and for each n I'd put a dot at the height, right? So if I had n equal to 1 and n equal to 2, and so on, I'd have a dot, I'd have some dot. Bounded means that there's always some boundary where all the dots stay within. Right? So it doesn't go up to infinity, or it doesn't go down to negative infinity. That's what it means to be bounded. Well, what's happening is n gets bigger and bigger. As n gets bigger and bigger, this thing is going to look more and more, the plus 1 in the denominator is going to play very little role. Right? So as n gets huge, this is really going to behave like 6n squared over n squared, which is just 6. And that actually should tell us what our guess is for the limit. So I'm going to go there first. Limit as n goes to infinity of an is really just, I just care about the biggest degree terms. 6n squared over 6n, which is going to give me 6. Okay, so what we've discovered is that this is always increasing. The limit is 6. But what's that mean? since it's always increasing and the limit is 6, that means that it has to be bounded by, on the upper side, by 6. And it's definitely bounded below by whatever the very first term is. When I plug n equal 1, I get 6 over 2. So it starts at 3, and then these terms will go up and get closer and closer and closer to 6. So yes, it's bounded, and the limit is 6.